Okay, we're going to start with 1746. It says a 5 kilogram mass is pulled to the right, so the mass is equal to 5 kilograms. It's pulled to the right by a 20 Newton force, so that's a applied force, and it's at an angle of 30 degrees. And then they tell me the coefficient of static and kinetic friction. So mu s is equal to 0.2 and mu k is equal to 0.1. Determine the acceleration. The first thing I'm going to do is draw my what's happening picture, which they have there. So I have this box, and it's being pulled with an applied force of 20 newtons, and this is acting at an angle of 30 degrees. The first thing I'm going to do is I'm going to draw my free body diagram. But when I'm doing that, before I even start, in physics, you have to establish your sign convention. So because this applied force is going to the right, I'm just going to write that this is the direction that it's moving. Why am I writing the direction that it's moving? Because I want to establish, so I'm just going to use my standard Cartesian sign convention that up and to the right is positive. And this is important for when I start to sum forces. So I want to establish my sign convention. The next thing I'm going to do is I am going to draw my free body diagram. So my free body diagram only shows the forces that are acting in the direction in which they act. So here's my applied force, Fa. Because Fa is going this way and that's the way it's moving, my frictional force acts opposite the direction of motion. Now remember, on the AP test, if they asked you to show this at the point of contact, your frictional force would actually be on the surface, okay, if they say a point of contact, okay. My weight acts down, and my normal force acts perpendicular to the surfaces in contact. And again, the normal force would act from the bottom, and the frictional force would act here. The next step is before I sum my forces, because it's moving this way, I'm going to sum forces horizontally and vertically. So that means parallel and perpendicular to the surfaces in contact. So I want all my forces to go perpendicular and parallel. So before I can start doing that, I have to look at my picture and say, is there any force or forces that are not going perpendicular and parallel? And that's my applied force. So what I like to do is I like to do it to the side. Why do I do it to the side? Just so I don't make a mistake. This is my Fa. Now remember, to get my component, this is where I start. So I'm going to go horizontal and see the direction in which this arrow goes. That's very important. So that's Fax. From the head of this vector, I do the tail of the other. Look at my arrow again. This is Fay, and this is 30 degrees. These are perpendicular to one another. So now I know that Fax is equal to Fa cosine of theta. Why is it cosine? Because it's adjacent to the given angle. So that's going to be 20 cosine of 30. So Fax is equal to 17.3 newtons. Fay is opposite the given angle, so it's Fa sine of theta, so it's 20 sine of 30, so Fay is equal to 10 newtons. Now I'm going to redraw this, and f of g is the same, f of f is the same, f of n is the same, and instead of Fa, I'm going to replace it with Fax and Fay. Now you notice that the directions of these arrows are just like I drew it here when I drew my components. So that's why when you draw your components, the direction is important for when I end up summing forces. Now, there's three things that I'm going to do on every single problem. So if you do it out of order, it's okay. But let's just remind ourselves, what are the three things that we're going to do? We are going to, one, sum forces horizontally. We're going to sum forces vertically. And we're going to use the mu equation. Those are the three things we're going to do. Where should I start? Before I start just doing these in this order, let's think about the problem for a second. This problem asks for the acceleration. So the acceleration is going in the x direction. So you know what? I'm going to do that last because I'm going to sum the forces in the x direction last because that's where acceleration is. And if I did it in this order, I would say, oh, I'm missing something. I need to go back. So what I'm going to do first is I'll sum in the y. Up is positive, so I'm going to show my sign convention. I'm going to say summation of f of y is equal to ma. Now I'm looking at this picture here. This is the picture that I'm using where I'm summing forces. Now, what forces are going in the y direction? Well, Fn is up, so that's positive. Fay is up, so that's positive, and that's equal to ma. Now, this block is not accelerating in this direction. It's not even moving in this direction. So this whole thing is 0. Oh, I forgot. Whoopsie. And then minus f of g, because f of g is going down. Now, I want to solve for f of n. So I'm going to rearrange this and say f of n is equal to f of g minus fay. I just moved it to the other side. So again, this is positive, and this is negative. Now, I'm going to substitute in my values. F of g is mg minus fay, which I already found was 10. So f of n is equal to 5 kilograms times 9.8. Again, I don't make this as negative because the negative is already taken into consideration there. So I don't do a double negative. Minus 10. So Fn is equal to 49 minus 10, so Fn is equal to 39 newtons. Now I'm going to use my mu equation. So mu is equal to f of f over f of n. So f of f is equal to mu times f of n. So f of f is equal to mu. So which mu am I going to use? I'm going to use the 0.1. Times 39, so that's 3.9. So now the last step, and the reason I chose to sum forces horizontally last was that's where the acceleration is acting this way. So I'm going to show my sign convention. Right is positive. Summation of f of x is equal to ma. Now this is not 0 because I'm solving for that. So now I'm going to look at my free body diagram. Fax is going to the right, so that's positive. Minus f of f is equal to ma. So now I'm going to rearrange the equation to solve for the unknown in terms of the known. So fax minus f of f over m is equal to a. So 17.3 minus 3.9 over 5, and that comes out to be 2.68 meters per second squared. Now again, the reason why I summed forces horizontally last was because I knew that's where the acceleration was. So I said that's going to be my last step. So I could have done the mu equation first, but then I would have said, oh, I need to know f of n. So again, I summed forces vertically, and I found f of n. Then I used the mu equation, and then I summed forces horizontally. So again, my 3 steps, if I do them out of order, that's okay. But those are the 3 things that I'm going to do on every problem. Is I'm going to sum forces horizontally, vertically, and I'm going to use the mu equation. So your free body diagram, that's the most, once you draw that free body diagram and then you break it into the components, you're home free. You're just going to do those 3 things, and that's it. But you have to establish your sign convention.